In this video, we're going to introduce nonlinear systems of equations and discuss solving using the substitution method. A system of two nonlinear equations and two variables, also called a nonlinear system, contains at least one equation that cannot be expressed in the form ax plus by equals c. A solution of a nonlinear system in two variables is an ordered pair of real numbers that satisfies both equations in the system. The solution set of the system is the set of all such ordered pairs. As with linear systems in two variables, the solution of a nonlinear system, if there is one, corresponds to the intersection point or points of the graph of the equations in the system. The graphs could be circles, parabolas, or anything other than just two lines. Also, as with linear systems in two variables, we can solve these systems using graphing, substitution, or elimination method. This is going to be a really important skill when you're in calculus and trying to find the area between two curves. You're going to have to find the points where those two curves intersect so that you can find the area. So we're going to discuss algebraically how to solve these systems, because when you're graphing things other than just two lines, it can be hard to just look at the graph and identify the points where the two graphs intersect. Well, one of the things I love the most about math is the overarching procedure does not change even when the problem gets more complicated. So you already know the solution method for systems of equations with just two variables, linear equations. We're going to use the exact same steps when we're looking at nonlinear systems as well. So for the substitution method, you're going to choose one of the equations and solve for one of the variables in this equation. I always just look for the one that looks easiest. Then we're going to substitute that expression for the solved variable into the other equation. We'll solve for the remaining variable. Then we're going to substitute this value that we got in step 3 in either original equation and solve for the second variable. We can always check our solution by plugging our ordered pair into the original equations. The only thing that's really different when we're looking at nonlinear systems of equations is we might get more than one answer. If we have a circle intersected with a parabola, right, we're going to have two intersection points. So don't feel thrown off if you get more than one answer. A lot of times we do. So let's solve this system. 2x plus y equals -5 and y equals x squared plus 6x plus 7 using the substitution method. We want to choose one of the equations and solve for one of the variables. Well, it definitely looks easiest to solve that first equation for y, so let's do that. Solving this first equation for y, we get y equals -2x minus 5. Now we're going to take this expression that we came up with and substitute it in the other equation for y. That's going to give us the equation -2x minus 5 equals x squared plus 6x plus 7, and we want to solve for our other variable, which is x. I notice this is quadratic, so I'm going to set it equal to 0. I'm going to move everything to the right so my leading coefficient stays positive. We'll factor x plus 6, x plus 2. So this gives us x equals -6 or x equals -2. So I've gotten two answers for x. That tells me that I'm going to have at least two ordered pairs in my answers. I'm going to take each one of these solutions individually and plug it into one of our original equations for y. Personally, I would actually plug it into this modified version of our first equation because it's just going to spit out the answer for y. So first I'll plug in the -6 for x. Y equals -2 times -6 minus 5. We get y to be 7. Our first solution is the ordered pair -6, 7. And then we do the exact same thing with our second solution. Y will be -2 times -2 minus 5. We get y to be -1. So our second ordered pair is -2, -1. If we go back and look at what our equations were, our first one is just a line and our second one is a parabola. So if we just think about that graphically, a parabola intersected with a line, we're going to get two solutions. The only time we wouldn't get two solutions is if this line was actually a tangent line to our parabola, but that does not happen very often. All right, so let's look at an application. We want to find the length and width of a rectangle whose perimeter is 40 feet and whose area is 96 square feet. Well, the first thing we need to do is get our equations. I'm going to draw a rectangle. They don't tell us anything about the length or the width, so I'm going to label these two x and these two y. The perimeter is 40 feet, so that'll be 2x plus 2y equals 40. And then the area, well, that's length times width with a rectangle, so x times y is equal to 96. Using the substitution method, we want to solve one of the equations for one of the variables. I'm going to solve this one for x. So x is going to be equal to 96 divided by y. We'll substitute this fraction in for x in our other equation. It'll give us 2 times 96 over y plus 2y equals 40. Multiplying the 2 and the 96, that's 192 over y plus 2y equals 40. Since we're solving for y, I need to get that y out of the denominator, so let's multiply through by y. That gives us 192 plus 2y squared equals 40y. Again, we're quadratic, so let's get it set equal to 0 and in descending order. 2y squared minus 40y plus 192 equals 0. I have a GCF of 2 that I can take out. And then this factors nicely y minus 8 and y minus 12. We're getting two solutions again. Y equals 8, y equals 12. And now we will plug each of these solutions into one of the original equations. But again, I would do the modified version because it'll just spit out the answer for x. So we'll plug our y values in, each one of them, into this equation and get our corresponding x values. X is going to be equal to 96 over 8 giving us x is equal to 12. So we could write this as an ordered pair. And then plugging y equals 12 in, we get x equals 96 over 12, x equals 8. So our second ordered pair is going to be 812. So basically what's happening with this application is that we're getting a length and width each time of 8 and 12. It just depends on whether we're looking at the rectangle this way or if we're looking at the rectangle this way. That's why we get the two answers for the same rectangle.